when it says to write the fraction in simplest form, what are we trying to do, or how would I go about this? What does it mean for it to be in simplest form? We got to reduce it. And to reduce a fraction, I want to look for a number that goes into what? Both of them, both the numerator, the top, and the denominator, the bottom. So I need some number that's going to go into both the top and the bottom. It doesn't matter if I see the biggest one first. Maybe I look at two numbers and I was like, I know that 2 goes into both of those. Beyond that, I'm a little bit stuck. It is okay to try small numbers. Then you look at whatever you get as a result and see if that can reduce any further. So let's look at number 1. I have 15 over 81. What kind of numbers go into 15? 3 or 5? Will 3 go into 81? Will 5 go into 81? No. So I can reduce both of these by 3. I can divide them both by 3. How do you know if 5 will go into a number? What kind of numbers would it have to end with if 5 goes into it? 0 or 5. So if a number ends in a 0 or a 5, then 5 will go into it. 81 doesn't end in a 0 or a 5. That's how we knew that 5 wasn't going to go into that. What is 15 divided by 3? Because that's going to be my new numerator. 5. What about 81 divided by 3? 27. Nice work. And now I have to stop and check to see if that is fully reduced. What will go into my numerator? What goes into this new numerator? What kind of numbers go into 5? It's prime, so 1 and 5 go into 5, right? Only 1 in itself. Will either of those go into 27? I mean, 1 will, but if I divide it by 1, will it change? So I'm never looking for if 1 goes into it, because 1 goes into everything. 5 doesn't go into 27, so I have a fully reduced fraction here. Number 2, 36 over 216. What will go into both the top and the bottom? I heard 6, I heard 9. Both of those are correct. Let's do 9. This is one that I didn't do when I was working through it on my own. What is 36 divided by 9? Is 4. What about 216 divided by 9? How much? 24. Oh, my calculator is dead. I trust you, but I'm still going to double check it. $24, absolutely. We reduced it. Is it in simplest form, or is there something that'll go into the numerator that'll also go into the denominator? 4 will go into top and bottom. So my new numerator, 4 divided by 4, is going to be what? 1 over 6. 24 divided by 4 would give me 6. Is that fully reduced now? Yes, that is fully reduced. The only thing that goes into 1 is 1, and if I do 6 divided by 1, it doesn't change. So something really interesting, because I did hear this around the room, but I kind of stayed quiet. 9 went into 36, and then with that answer, I could also take another 4 out. So if I'd wanted to know, did I find the biggest thing at the beginning? Well, if I can reduce it again, I didn't find the biggest thing at the beginning, but remember, that doesn't matter. You want to take it until you can't reduce it anymore. But if you wanted to know what was the biggest thing that goes into both of these, the numbers that you divide by here, if you multiply those together, that will give you the biggest thing that would go into those. What is 9 times 4? 36. So 36 goes into both the top and the bottom. you guys have any questions for me on the warm-up? We're going to hop into your books. So these books pick up where your first semester books left off, and they did that including the page numbering. So this book does not start off at page number 1. We are going to start off on page number 461, but it's only about 1/4 of an inch into your book. Page 461, but it's not very far into your book at all. We are going to learn about something called dilations. When we dilate a shape, it's going to change the size but not the shape. So when you're in a drawing program and you resize something, you take a shape that you really like and you're like, ooh, I like that, but I want to make it bigger. That's a dilation. The shape stays exactly the same, but you've enlarged it. Or maybe it's too big for what you want to do and you need to make it smaller, so you reduce that size. You have a reduction. That would also be a dilation. So taking a shape and making it larger or smaller would be a dilation. It maps an original figure, which we call a pre-image. The original figure gets called our pre-image, onto a new figure that we call the image. Dilations are a type of non-rigid motion. We say it's non-rigid because it changes the shape itself. We studied rigid motions back in first semester. Do you guys remember when we did translations, the slides? And we did reflections, the flips, and rotations, the turns? Those are all types of rigid motions. Those are things that if I had little tiles for my 7-year-old daughter to play with, I can model a translation, a reflection, or a rotation with those tiles. But in a non-rigid motion, because I'm changing the shape of it, I can't model that with something that she could hold in her hand. It is going to either enlarge or reduce the size of our shape. The sides of the image are proportional to the sides of the original figure. When I say proportional, I mean that we're going to have a fraction equal to another fraction. So I want to kind of draw what that's saying there. So I've got 2 triangles, one larger than the other. And instead of putting numbers on the sides, I'm going to let letters represent the lengths of these sides on the triangle. So I'm going to call this side A, B, and C. And then on my larger one, we're going to call this D, E, and F. When we say that the sides are proportional, I have to make sure to match up my corresponding sides, so like side A and side D. If I set up a fraction with those two, and it doesn't matter which one I put on top and which one I put on bottom, as long as I stay the same for the next fraction. So I went with my smaller triangle side over my bigger triangle side. That fraction would come out to be exactly the same as when I put the length of side B over the length of side E. And that fraction would be absolutely identical to when I put side C over side F. All three of those fractions would be exactly the same. They might need to be reduced, like we practiced on the warm-up. So I might have one fraction that's 1 over 2, but another fraction that's 3 over 6. But when I put both of them into my calculator, I get 0.5. How much we're changing the size of our original figure is called the scale factor. This is the ratio, that's another word that means fraction again. This is the ratio of the length on an image. Remember, that's my new figure. To the corresponding length on the pre-image. That's my original figure. So if I was going to write down a formula for scale factor, scale factor is equal to the new over the original. Instead of writing out the word scale factor, or even abbreviating it SF, sometimes they'll use the letter K to mean scale factor. So all three of those are perfectly interchangeable. You can write out both of those words, scale factor. You can abbreviate it SF, or you can use the letter K. They all mean scale factor, how much we're changing the size by. A dilation will produce shapes. In this case, we had two triangles up there that are similar. That little squiggle there means similar. If I have shapes that are similar, their sides will be proportional. And their angles will be congruent. Sides are proportional, angles are congruent. And then the last thing that I want to talk about before we actually start practicing some of this has to do with our scale factor. When I have a scale factor that is greater than 1, that is an enlargement. When I have a scale factor that's between 1 and 0, that will give me a reduction. Which one of those two words, enlargement or reduction, would mean makes it bigger? Enlargement. And so then makes it smaller would be reduction. One thing that I want to point out before we go on and look at the next example. Always check on a calculator when the scale factor is a fraction. The reason I say that is because a lot of times students, when they see a fraction, they automatically say, oh, that fraction is going to be smaller than 1, because if it wasn't, they would have written it as a whole number. When my numerator, the top part of my fraction, is bigger than my denominator, it's going to come out to be some number that's bigger than 1 because the top was bigger than the bottom. If the top part of my fraction is smaller than my denominator, then we're going to get some kind of a decimal on the calculator that starts with a 0 point something, something smaller than 1. So whenever they give it to you as a fraction, pop it into your calculator, divide those two numbers just to make sure that you're getting it correct, whether it's an enlargement or a reduction. Let's actually start to use some of this now. Let's look at example number 1 down at the bottom of the page. It says determine whether the dilation from triangle ABC, since this is what I'm starting from, this is my original shape. I'm even going to draw that on this picture here. This is my original. To triangle DEF, so this is my new shape. Determine whether the dilation from triangle ABC to triangle DEF is an enlargement or a reduction. And then find the scale factor of the dilation. So if I start off with this shape right here, and then I multiply it by a scale factor, and that gives me this shape down here. Did it get bigger or smaller? It got smaller. Triangle DEF is smaller than triangle ABC. So that means the dilation is an enlargement or a reduction? Reduction. To find our scale factor, we're going to divide the side length of triangle DEF by the corresponding side length of triangle ABC. So remember, scale factor is equal to new divided by original. I only have one side length on my new triangle. What's the side length that they gave me on the new triangle? 2 centimeters. So that would go up in my numerator. There's my new. What's the corresponding side length on the other triangle? 6 centimeters. So 2 over 6 is my scale factor. Can we reduce 2 over 6? Is that in simplest form? Not in simplest form. We can reduce it. What'll go into both 2 and 6? 2 goes into both. So I divide top and bottom by 2. So what would my new fraction be after I reduce this? 1/3. 1 over 3. Nice work. One thing yet that I want you guys to write down at the very bottom of the page, you have a little bit of margin down there. To go the other direction, and by other direction, I mean, what if triangle DEF was my original shape? And my new shape was triangle ABC. If DEF was the original and ABC was the new shape, would that be an enlargement or a reduction? That'd be an enlargement then. And so to find my new scale factor, I would flip the fraction around. So that scale factor that we came up with of 1/3, if I flip that fraction over, I would get 3 over 1. Is that in simplest form? What is 3 divided by 1? 3. So if this went the other way around, the new would be the 6, the original would be the 2, and so then I'd have a scale factor of 3. So anytime I know what the scale factor is for a reduction, I can flip it around to find the scale factor for the enlargement. Or vice versa, if I know what the scale factor is for the enlargement, I can flip it around and find the scale factor for the reduction. So far, so good? All right, let's flip the page. Determine whether the dilation from trapezoid WXYZ, so here's my original, to trapezoid JKLM, so here's my new shape. Determine whether that is an enlargement or a reduction, and then find the scale factor. If I start off as WXYZ, and then it becomes JKLM, did we get bigger or smaller? Smaller. So would this be an enlargement or a reduction? Reduction. And then they want us to find the scale factor. Remember, for scale factor, we do new over original. I know the longest side of JKLM. What is the longest side? It's the only one they gave me a side length for. 4 over, what's the corresponding side on the original shape? 7. They gave us units with this, 4 meters, 7 meters. Doesn't matter. I don't care about that at all when I'm writing scale factor. The units do not matter. So you can just write down the numbers when we're talking about our scale factor. What about if this was backwards? If we'd gone the other way, would it be an enlargement or a reduction? An enlargement. With a scale factor of what? 7/4. Would this come out to be a number bigger than 1? Yes. And how do I know even before I put it in my calculator? Yep. Top 7 is bigger than the bottom 4. If the top is bigger than the bottom, then it'll come out to be a number bigger than 1. Let's look at example number 2. Some things I like that your book does here. There's a whole bunch on this particular problem that I don't like, so we're going to make it easier than your book does it. You guys okay with that? If we make it easier than the book? Okay. It says Jaleel is printing a banner for his school's wheelchair tennis team based on the design shown. By what percent should Jaleel enlarge his design so that the dimensions of the banner are 5 times that of the original design? If I want the percent, I'm going to do my scale factor times 100%. So if I want it 5 times bigger, by what percent are we increasing this? 500%. I would do 5 times 100%. So we would want it 500% bigger. That part that your book did wasn't so bad. This next part, they have you multiplying by the percent. That's doing too much. To find the dimensions of the new banner, I'm going to take the dimensions of his original design, and we're going to multiply those by our scale factor. So we're going to multiply by 5. If the dimensions of the design are 6 inches by 14 inches, what will be the dimensions of the finished banner? 6 inches needs to get 5 times bigger. What is 6 times 5? 30. So this would be 30 inches. That would be my width. What about the length? 70 inches. So the banner is going to be 30 by 70. I want you guys to try the check that's down at the very bottom of the page. You're going to choose which of those options, A, B, C, or D, is correct. I'm going to give you about 2 minutes to do that, and then we'll check your answer with mine. I want you guys to do the check at the bottom underneath this problem. Choose A, B, C, or D based on what they've given you. They said it's supposed to be 2.5 times that of the original. So which percent is right? 125% or 250%? 250%. We do 2.5 times 100%. That's how we get 250%. So which answers can we cross out right now? A and B. But then we still need to figure out whether it's 22.5 centimeters by 30 centimeters or 45 by 60. Which one of those is correct? D, 45 by 60. 18 times 2.5 gives us 45 centimeters. And 24 times 2.5 gives us 60 centimeters. Nice work. There's one more thing that we're going to touch on before we end class today, and that is when I have a dilation, an enlargement, or a reduction on the coordinate plane. So when I plot it on an XY axis. We're going to talk about that next. That's going to be over on page 463. top of the next page. To dilate a figure by a scale factor of k with respect to the center of dilation, which on an xy plane is always going to be 0, 0 for my center of dilation. We are going to multiply the x and the y coordinates by k. So if I have my original xy pair, I'm going to take the x part and I'm going to times it by k. I'm going to take the y part and times it by k. That's what this says right here. Take the original x, multiply it by k. Take the original y, multiply it by k. Let's give that a try. Example number 3. I have a triangle, so I have 3 points plotted, 3 vertices. -4 times 5, or sorry, -4, 5 is point T, 0, 6 is point R, and 4, 3 is point S. And I want to dilate that by what scale factor? 1/2. So is this going to be an enlargement or a reduction? Reduction. My scale factor is less than 1. In between 0 and 1. So I'm going to take each of these ordered pairs. We're going to multiply the x part by 1/2. We're going to multiply the y part by 1/2. That's what they're showing us right here. -4 times 1/2 gives me -2. -5 times 1/2 gives me -2.5. We do the same thing with point R. What happens when I do 0 times 1/2? I get 0. What about 6 times 1/2? 3. And then we do the same thing to point S to get S prime. We're going to take the x part 4 times 1/2. What's 4 times 1/2? 2. And then we do the same thing with the y part. What is 3 times 1/2? 4 times 1/2 is 2. What's 3 times 1/2? 1.5. Kind of like you got $3 and you spent half your money, you have $1.50 left. I want you guys to try this on the check that's down at the bottom of the page. Again, take about 2 minutes to try the check down at the bottom. What's our scale factor this time? Scale factor is 4. So is that going to be an enlargement or a reduction? Enlargement. The point x is 3, -4. So what would x prime be? -12, -16. Absolutely correct. We take x, both parts, times it by 4. What about y prime? 2420. And what about z prime? 32, negative 8. One more thing quickly before you guys pack your books up. We're going to go to the next page for just about 2.5 minutes. And then we'll shut it down. When I have these two shapes already plotted, I can go backwards to find my scale factor. There's something I don't like about the way your book drew this picture, though, and that is they didn't draw the rest of the x or the y axes. So I want to find some ordered pairs here. Help me out. What's the ordered pair for point A right down here? Close. Negative 3, 0. What about for point B right up here? 0, 2. What's the ordered pair for A prime? Negative 9, 0. B prime? Zero, 6. Which one of those do you think is my original one? ABC or A prime, B prime, C prime? ABC. This is my original. And so A prime, B prime, C prime is my new. To find the scale factor, we do new over original. By the way, I did not like the way your book did this at all. They made it way too long and complicated. So new, a point like A prime, or B prime, or C prime. Original, points like A, or B, or C. To find my scale factor, I can do the x part of A prime divided by the x part of A, or the y part of A prime divided by the y part of A. Or I could do the same kind of thing with B and B prime. Do you guys want to use A or B? A sounds good. Does it make sense to use the y parts of point A and A prime? What's the y part of point A? 0. What's the y part of A prime? 0. If I do 0 over 0, is that going to help me figure out my scale factor? No. So let's do the x part. It doesn't matter whether I use the x part or the y part. I'm going to get the same thing either way. So I would have negative 9 over what? Over negative 3. Or if we had chosen point B, I would have what over what? 6 over 2. Either way, no matter which one I do, I get a scale factor of what? What is negative 9 divided by negative 3, or 6 divided by 2? 3. Thank you. So we get a scale factor of 3. There were 2 papers that you picked up on your way in the door today. One of them was the warm-up that we worked on already. The other one is your homework that's due on Wednesday. Homework's due on Wednesday. Have a fantastic first day back, second semester, and I will see you guys tomorrow.